High class, we want to use a plot of temperature versus pressure to see how we can find the heat of vaporization. But as we said, the plot of temperature versus pressure will give us a curve, and with that we will not be able to get the heat of vaporization. But when we use a plot of ln P versus 1 over T, we are going to get a straight line graph, and from there we are going to use it to calculate the heat of vaporization. So let's draw the graphs and let's examine it. So to draw the graph, go to Excel, Microsoft Excel. Then when you get the highlight, then you click Insert. Insert, go to Charts, click Insert X, Y or bubble chart, click it, but check this one, the first one. So when you get this chart, please make sure you label it. So we are going to label this. So we are labeling the chart, which is vapor pressure versus temperature. Now let's label our axis. Click this plus sign. So here will be vapor pressure on the y-axis. And you know it's in tau. Then we'll label the x-axis, which is temperature. Degrees Celsius. We've labeled our axis. But now, let's fix the axis. Let's fix our scaling. So please double click, and you see that we have a minimum for temperature is supposed to be 200, but what we have here is 0. That's not correct. So let's put 180. It fixes our scale. Then now click this dot, then right click. You see add trend line. Add the trend line. But you see we cannot have this because it doesn't go through, it goes only through one point. Now go to exponential or test any of this. The one that fits the points, many points, that's the one you take. So then you go to display equation chart, click it, then display R square. Please don't touch set intercept. So now you see we have our equation of the line, but it is exponential. We cannot get much out of it. We want to find the heat of vaporization. So now you can change this. You can change this. So when you click this, you can go to this and you can change it to, no, we don't want that. Let's click it. You can change it to a solid line, and you can even change the color. I'll change it to orange. So I change the color to orange. You can change it to any color. You can change it to red. That's okay. So you can change it. You can do anything with this Excel. Then now I want to clean it. I normally like my graph to be clean. Click those lines and delete them. Delete. So your graph is clean. But with this, we cannot have any good information with this graph. So that's why we want the linear form of the graph. Because all what we want, we are searching for heat of vaporization. So the linear form of the graph, we have to plot 1 over temperature versus ln P. So now let's calculate it. Click this box, put equal sign, then click temperature. Put 1, then divide it by temperature, because that's what we want. Then put enter. Then now go back here and pull it down. Then you get 1 over temperature for all these values. Then go to this ln P. We want to find ln P. Put equal sign, then ln. You see that you have everything, but find the one that we want. Return the natural logarithm of the number. Click it, then go and click the numbers. This is this one. Put enter, then go back and pull it. So we have our values. Please, I want us to change the font. Let's get it to 16 so that we can see it. Okay, this is the font. You can even reduce the decimal, please. So, oh, that's too much. Okay, we can have it like this. So now we want to plot a graph of ln P versus 1 over T, because that is what will give us a straight line graph. So highlight it, go back to insert, click charts, and click this. So you have it here. Label your graph. That's ln P versus 1 over T. Now go label the axis, click the plus sign, put axis title. So this is ln P. Here is 1 over temperature, 1/T, which is degrees Celsius. That's the unit. So now we want to fix our scale. In the x-axis, our smallest value is 0.003. So click here, put 0.003, enter. The y-axis, we are okay. Now click here to add equation, right click, add straight line. So you see we have our straight line. Then click equation of the line, arrow square value to see how the values fit to make a straight line. So that's our equation of the line. You can change click this cup, change the color. I like this. Then you can change, put it to solid line. So that's it. What else can you do? You can change the font of this so that you see the equation of the line well. Go to home, change the font to maybe 16. Okay. Oh, that's too large. Remove this. I normally like to fix it. Delete it. Click these lines and delete. So that is our graph. So this particular graph, our y, which is ln P, so our y equals to mx plus b. So our y equals to ln P equals to -3,773 0.5 x plus 18.692. So we can still write this as lim P equals to minus 3773.5 1 over t plus 18.692. So this is our equation of the line. So we are going to use our data. So our minus 3773.5 equals to minus delta H verb all over arrow. And you know arrow is a constant. Arrow is a constant. .314 joules moles Kelvin. So 8 minus 8.314 joules, 314 joules moles Kelvin as the unit times minus 3773.5 K equals to delta H vaporization. Cancel K, then multiply. So 8.314 times 3773.5 equals to 2.879 joules per mole. Delta H vaporization. You can change it to kilojoules. So this is our heat of vaporization, or to how many significant figures? How many significant figures do we want? We want 3. You can change it to 3 significant figures. So this is how we get the heat of vaporization graphically. So thank you. Make sure you practice it, do your homework.